Yeah, hi, good evening, guys. And today I will be sharing an interesting idea about the SIR modeling. So why I chose this topic is like kind of really interesting. Like for the first few days, one of our students, like named Tanveer, was talking about a lot of like when I was discussing probability and I was asking about modeling using the discrete distributions. They were talking about a lot of probabilistic aspects and then I asked him about the corresponding application. So he was mentioning about this SIR modeling and stuff. So I sort of thought of doing, since I have completed discrete distribution, so I sort of planned of doing this interesting idea, an application of this discrete distributions. Okay, so essentially on a broad basis, I will sort of teach you Markov chain ka really basic stuff. Okay, and that will be the application part, and like that will be the theoretical part, and like it will be needing we will be needing conditional probability and really basic conditional probability and basic linear algebra. So you will see the connection between linear algebra and probability in matrices sort of now. Okay, so that is like a really interesting aspect to it. And but I will motivate the problem using the example of this HIV problem. Okay, and how it's really done in the real. Like I had epidemiology in my course, like I just passed out, I just graduated from college, and I had epidemiology as a special paper, and I sort of learned this there, like in a broader framework. But this framework is really interesting and really yeah, so really interesting. So I'm really excited to get started. And so coming back to this problem, so coming back to this problem, what is really there, it revolves around the fact. I will motivate the problem now using this biological example. The problem is this, that you have, like let's say for HIV virus, so we are trying to understand the growth with respect to the infection state of a person, of infection state of a person. So I will be defining the random variable over here so that you can understand it totally. So initially we have like understand how it really happens. So essentially this is also the first modeling of COVID-19, whatever I'm telling you, so that you can understand like how COVID really happens, like how the modeling of COVID in real life happens. So understand that initially there are like exactly there are three states. Okay, the number one state is susceptibility. Okay, like I am a susceptible being to COVID, okay, or HIV or any other disease. Okay, susceptible means to whom the virus or the disease can, like who can capture the virus or the disease. Okay, that person is called susceptible. So that is a certain state. Okay, and another state is infected state. Okay, and another state is removed state. Removed may, there are two type of people. One who has recovered, who is immune to the disease, and the third is the second, like one is immune, other is who are removed, like sort of dead. Okay, after the disease, in like immune. So these are the three states. Okay, so what I will do now is really interesting. What I will do now is I will define a random variable which can take these three values. X ka X is a random variable which can take three values. Okay, so X is not a random variable, it can have three values. We like it cannot take X is a random variable means X must be taking values in the real number line. Okay, so instead of this we'll just define it as 0, 1 and 2. Instead of this names, we'll be defining as 0, 1 and 2. Okay, so what exactly we are doing? X is taking values, so X is taking values 0, 1 and 2. So it's a discrete random variable. So X is a discrete random variable, and with probability P0, P1 and P2. Okay, so where does S like X fit in here? So what I will be doing is that the idea is very simple. What I will be doing is the following, that we will see the proportions of susceptible persons, infected persons and removed person. So this SIR modeling comes from susceptible, infected, and removed. Okay. So we will see the proportions. We will call this P0, P1, and P2 at time point 1, and we'll call that random variable x1. Okay. We'll call the random variable x1. Again, what happens? It will change on to a different population. Let's say we are checking at some intervals. So it changed to this population. Another P0 dash, P1 dash, P2 dash. Okay, at x2 time point, it changed there. But you see, x1 and x2 will not be independent. Okay, x1 and x2 will not be independent because they will have some relationship among them. And that relationship is exactly what we are going to study now. And that exact relationship is modeled by SIR. Okay. So this is the relationship we are trying to understand by SIR. So what is the idea? The idea is really interesting. The idea tells that, so okay, any doubts till this point of time in understanding the whole thing? Any doubts? I hope everyone understood the background. Any doubts, guys?
Sir, what ISI stands for?
What?
Sir, what ISIR stands for? Can you repeat?
Sure. So S stands for susceptibility, I stand for infected, and R stand for removed. Okay. So a susceptible being can be like in the this is like this. Initially, like what happens, like one susceptible being can be susceptible. Okay. Again, in the next step, like let's take an individual being, any individual being. If that person is susceptible, that person can again become susceptible. Okay. If that person is susceptible, that person can become infected. That person can become immune also somehow. That is removed also. That person can become dead. So removed also. Okay. If someone is infected, that person can not become susceptible. Like HIV is a virus where if you are once immune to it, okay, or if you are dead, then it will not, you will not become like you are like immune for the rest of the lifetime. Okay, it's unlike COVID. So that's why that was the first starting point, that COVID cannot be modeled by SIR per se. No, I mean it can be modeled. Yeah, I'm so sorry. It can be modeled when infected becomes susceptible. Okay, but there are certain limitations of it. I will tell you at the end of the lecture. So I cannot become S in case of HIV. Okay, so it will be zero over in some sense. Like I will tell you what the zero means. It is not possible. I can again become infected. I can again become recovered, okay, or removed. This is the next idea. Okay, next part is that the removed person or removed, that person, if already that person is immune, okay, that person can never become susceptible or infected. That will always be in the removed region. So this is the transition, like from a susceptible being you can go to susceptible, immune, and R. From infected being you can go to susceptible, infected, and R, removed. And from removed being you can only go to removed being. So what we will do now is that we will understand, we'll model this by the probabilities. Okay, we'll model this idea about probabilities from a susceptible being. What are the corresponding probabilities that it can go? This is the main idea, and this is exactly what we'll call as transition matrix. But we'll make you understand. I will make you understand in a much more theoretical framework. But this is the basic idea. Any doubts till this point of time? I hope not. Everyone understood the basic idea, what, like the problem we are going to attack. So we are trying to understand where x1 going to x2, and then what will be the x3 given this information. So we will understand it. Okay, we'll understand it. Thank you, Abhirob, for the boom. Yeah, so for the new person, Shuprovo, so if you like something you have to tell boom. If you don't like, you can say something, anything else, but if you like something you have to tell boom in the comments.
Sure, sir, sure. I will definitely say.
Okay, so yeah, let's understand this. So what we're trying to understand, what is the random variable over here? So first, defining random variable. The random variable is what? It takes values 0, 1, and 2. We have already decoded what 0 means. 0 means susceptible, 1 means infected, 2 means removed. Okay, so here the values is sort of, it's hot like it's like encoding. It's the real numbers doesn't mean anything. Okay, here what exactly it means is the P0, P1, and P2, the probability. ठीक है, these are the initial probabilities. So this is a random variable we are interested in. ठीक है. And each of the random, so what we are collecting or understanding is that we are understanding at time points 1, 2, 3, 4, the different p naughts. The p naughts are changing actually. P1, p naught, P1, P2 is this here at time point 1. P2, p naught 2, p naught, P1, 2, like here also the probabilities are changing in the next time point. Okay, P0, P1, P2 with 2, 2 and 2. So this is a probability change. So we want to understand how these probabilities are changing. Okay, that is our main idea, and that is where we will use conditional probability to understand the entire problem. Okay. So let's understand this, how to use conditional probability to understand like this entire mathematical problem. So the idea is that we will mathematically modeling by probability. So what is the idea? So we have these stats that susceptibility say what is the probability that xn the nth step mein you will become susceptible. So let's understand this. From xnth minus 1 step, n minus 1th step, from susceptible you can become what? You can become susceptible again. Okay. So given xn minus 1 is equal to susceptible, you will again become susceptible. Let's model that probability by p1, p00. I will tell you why p00 I am writing. This is sort of 0. This is sort of 0. I mean this from this idea. We'll also understand probability xn is equal to 1 given xn minus 1 is equal to 0. That is from susceptible to susceptible. This is from susceptible to infected. So this is probability, like let's make it p01. That is from 0 is going to 1. Similarly, probability xn is equal to 2 given xn minus 1 is equal to 0. Let's call it p. Can you tell me what is the sum of these three probabilities? Can you tell me what is the sum of these three probabilities?
Sir, 1.
Why it's 1?
So because
yeah, anyone. Because no other case, right? So from xn is equal to 0, like next step man, you have to go only xn can take only 3 values. So this is the probability must be 1. So I will, because I told you this because this is something to do with our interesting problem. I will tell you everything at the end of the video. Like many problems are given in your ISI MStat and IIT JAM with this certain idea. Okay, and you don't know maybe, but since we have read this, we know that. So now at the end of today's video, also you will understand like what people really do over there. So okay, so this is the main idea. Okay, so let's say we want to understand the probability xn is equal to. So similarly, we have what? So we have what? Understand that we have probability 0 to 1. We have probability 0 to 2. We have probability 0 to 2. We have probability 0 to 3. Okay. Similarly, we have probability 1 to 1. We have probability 1 to 0. Sorry, here 1 to 1, and here probability 1 say I think it will be 0. So let's write it in terms of susceptible infected R, and then I will change it to that numbers. So probability susceptible to susceptible, probability susceptible to infected, probability susceptible to recovered. Again, probability susceptible to, not susceptible, sorry, from infected to susceptible, from infected to infected, from infected to recovered. Like what are the meaning of this? Probability I comma j means probability of xn minus xn step mein it's j, given xn minus 1th step mein it's I. This is the basic idea. This is the basic definition. Why I'm writing in terms of matrix, I will share with you. Okay, I will share with you why I'm writing in terms of matrix. So next, probability last one क्या होगा? Probability recovered से infected, probability recovered से susceptible, infected and recovered से infected. So can you tell me, like, can you tell me these individual probabilities, something about these individual probabilities? So I have given you an idea about what can happen here. So can you tell me the individual probabilities about this? Like, what can be, like, tell me about these three probabilities mainly. These four probabilities. What is PIS? That is probability xn is
Zero.
It must be zero, right? Because
Yes, sir.
from S one can go to only from infected one cannot go to susceptibility back. So PIS is equal to zero. PRS मतलब recovered से susceptible जाने का probability.
Zero.
PRI
Zero.
and PRR also is zero. Is also one. Sorry. So this is the basic idea about this probability. So we want to understand this probability here. Okay. So this is one of the most important ideas also to understand the probability over here. Okay. And let's understand this probability. So why? So next question is that why I wrote in terms of matrix. So this is something called, okay. So I will tell you why I wrote in terms of matrix. Why a matrix? So what is our aim? Our aim was to understand the probability x is equal to s, probability xn is equal to x, probability xn is equal to I, and probability xn is equal to r. Our aim was to understand this only. Okay. Given the information we know about xn minus 1, probability xn minus 1 क्या है? Probability xn minus 1 में ये होने का probability क्या है? ठीक है? And we also know this information. We also know the previous step, and we know how it interacts, like how it changes using the this information, this information. Okay. So we know what we want to know the previous step, and we know how it changes using the information PAIJ. So from this we will understand what is the next step. So this is the basic idea of Markov chain. We know the previous step. Okay, we know how it's changing by the probabilities we have shown here. From that we will be understanding what is the next step, and for that we will be using conditional probability. Okay, you can understand it. So can you tell me, like, what is probability xn is equal to s? Can you tell me how we can write it using law of total probability? I have taught you law of total probability. Using the information of this, how it changes, that is xn given xi. So you know the information that xn given xn minus 1, and you also know the information of xn minus 1. How you can use this to understand the probability of this? This is exactly what conditional probability is doing. Can you tell me? Can someone tell me? Okay, I will select the person. Wait. Sneha, bolo. How do you do this? Tell me. I'm sure you can tell me this. Like, it's very easy. So you know the information of xn given xn minus 1, and now you know also you know xn minus 1. So how we can do this? Tell me.
So probability of xn minus 1 into probability of xn given xn minus 1.
No, this is not a probability. There is nothing called probability of xn minus 1. We write probability of xn minus 1 is equal to something, but this is not a probability. So you're on the right track. You're on the right track. So you do in case of that event. Probability of an event B is equal to probability of event A is equal to A given B given A into probability of, like, B intersection. Yeah. Bolo. 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 Okay. Anyone else who wants to tell? Okay. Sneha, bolo. Yeah. Tell me.
So we have to apply law of total probability, right?
Yeah. So what are the information you have? You have the information probability xn is equal to I given x minus 1 is equal to j, and we have the information probability xn minus 1 is equal to j. So what do? So you have this information. So what do you do?
So,
Yeah, bolo.
so probability of xn equals to s
Yeah.
into the probability of xn
Huh?
uh,
So what are the possible cases it can happen? Xn minus 1.
SIR.
SIR. So can we like write like this? Can we write like this?
yes, so
Okay. So after writing like this, what we can do? Good, Sriteja. Right. So what we will do is this. Probability xn minus. Understand this. What we are trying to do. Understand this very carefully. Let's draw a tree diagram. We always draw a tree diagram. There's a monthly test problem given in tree diagram. Xn minus 1 can take what? S. Xn minus 1 can take I. Xn minus 1 can take R. So from here, you go to, from xn, you are going to xn, right? Xn is equal to S. So how we can go? You first understand what values it can take. This is the event. So this is the another event. Xn minus 1 is equal to S. Xn minus 1 is equal to I. And xn minus 1, sorry, and xn minus 1 is equal to R. From here you go to here, here, and here. So what is this? If you remember the whole thing, this is probability xn minus 1 is equal to 5. This is probability xn minus 1 is equal to I. This is probability xn minus 1 is equal to R. And what is this? This is a given, you know this information. What is that? So xn is equal to S given xn minus 1 is equal to R. This is probability that given that. That is, this is what? Therefore, it's P RS. This is P. This is P IS. This is P SS. So what we are getting? We are getting probability xn minus xn is equal to S given xn minus 1 is equal to, sorry, xn is equal to S is what? Is coming out to be probability xn minus 1 is equal to S into P SS plus probability xn minus 1 is equal to I into P IS plus probability xn minus 1 is equal to R into P RS. Okay. So how we can write this mathematically? Let's understand. Okay, all of you understood this, guys, till this point of time? Did you understand this, all of you? Thank you, Shubhrabhu. Others? Good. Aishwarya, okay, fine. Sritajata understood. Yash, I hope you're understanding.
yes, sir.
Okay, so let's understand how we'll write this now. So what we are getting? Let's call it P. So let's make it a diagram. Nth position में, let's call it P1n. Okay, or let's call it pi1n. Let's call it pi2n, or let's call it pi3n. मतलब ये probability है susceptible, infected और disca. Or let's call it, let's not make it 1. Let's make it a bigger so that you can understand. Pi Sn S and N pi I and n and pi r and n. These are the probabilities of the nth step. That is, this is the xn with the xn is a random variable with the corresponding probabilities. Okay. And what is this? What we are having? This we are having as, understand, what we are having s nth में क्या होगा, p xn minus 1. So this is what? This is n minus 1 s or sn minus 1 into pss. So let's understand this. So you're getting ps, so pss into psn minus 1 plus pis into pi n minus 1 plus p rs into pr n minus 1. All of you understood this, guys?
Sir, why we multiply?
That is what it
This
came
P-
over here.
Oh, okay, sir. Got it, sir.
Okay. Similarly, we will get here what? psi into pin minus 1. Sorry, psn minus 1 plus p okay p what I into pin minus 1. I'm just marking it like this. Plus here p ri into p rn minus 1. Similarly, here we will get p sr into p rn minus 1 plus p ir into p
I'm
in.
sorry. Yes, I will be pi exponential.
No, I will tell you what is that. That will not be equal. Like it's intuitive, it's not equal. Like from what the probability of becoming susceptible from an infected is not same as probability of becoming susceptible from infected from susceptible, right? Follow me. It should not be same. Suppose I am infected with HIV, the probability of me becoming susceptible again is 0. We have done that now. We have understood that PIS is 0. But the probability of me me being infected again, being not infected with HIV, is not 0. You understood? It's not symmetric. Did you understand that? Good. So therefore, what we are getting is the following: that here we are getting therefore P RR into P Rn minus 1. Okay, all of you understood this equation, guys? All these equations you understood? All these equations you understood, guys? Write a boom in the comments if you did. Yeah, I'm writing for transition matrix. You're right. Thank you. Aishwarya, understanding? Do you need this stuff in your data analysis work? Yeah, thank you.
So is this a matrix?
Yeah, I will tell you how it is becoming a matrix. Okay. So
Okay, sir.
let's understand that. Let's take this as a vector. So what is this p? This is actually not p. I mistakenly wrote it. It's actually pi. It's really pi. We have denoted by pi actually. And sorry for the messy part. I cannot help. So understand, like if you now rub these things off, like if you take this as an nth vector, as a vector now, this is an nth vector. The probabilities, this is another nth vector of probabilities. Not sorry. This is a vector. Understand that this is what? If you take this as a P matrix, that is equal to PSS, PIS, PRS, here PSI, PII, and PRI, and if you see PSR, PIR, and PRR, then observe that what exactly we are doing is that we are multiplying this matrix. This is what? This is this times, let's call this row vector R1, this row vector, let's call this row vector RS because it's going from susceptible, RI, and RR. Then this is what? This is actually RS vector dot product, the this is a pi n vector, this is a pi n minus 1 vector. Understood? This is a pi n minus, do you understand this, guys? This is a dot product of this row vector and the pi n minus 1 vector. That is pi s n minus 1, pi I n minus 1, and pi R n minus 1. Okay. Similarly, if you multiply this, you will see that you will get this results. Do you understand this, guys? Did you understand this? All of you? Yes or no? Anyone who didn't understand? Do you want me to repeat? Okay. Sure, all of you understood? May I continue? Okay, perfect. Now this is the most important logical step. So what we are getting? We are getting that pi nth vector is actually equal to this P matrix times pi n minus 1th vector. So this is the result we are getting. Okay, this is the result we are getting. So understand this, that what is really interesting is the following, that if you want to understand where this pi n goes, where this pi n goes as n tends to infinity, that is what our aim is, that after a certain time where this pi n will go, where this pi n will stabilize, assuming that this there is no this is a basic idea, where this pi n is changing and going. So finally towards the end. So that is the aim. So understand that Pn, understand what we have got here. So Pn, pi n is equal to, so pi 2 is equal to what? Pi 1. Initially that was there. Pi 1 is equal to P pi 0. Pi 3 is equal to P pi 2. Karte karte, pi n is equal to P pi n minus 1. Can you tell me, can you write down pi n in terms of P and pi 0? Can someone tell me what is pi n in terms of P and pi 0? Pi n is the probability vectors, like the xn ka probabilities. Xn ka probabilities, the nth random variable probabilities at the nth time point. So it's equal to what? Can someone tell me? Did you understand that? Therefore, understand here that what is pi 2? If you just replace pi 1 by this, you will get what? P square pi 0. So it will observe that it will be to the power n pi of 0. So if you know the initial probability at the initial time point, the distribution of the probabilities, which you can collect it from the data, and you can observe the probabilities over time, you will get this Pn, how this Pn actually makes sure how the pi n goes after n years, n time points. This is the basic idea. Did you understand, guys, all of you, or no? Any doubts? Do you want me to explain it again? Yeah? You want me to explain it again? Clear? Okay, once more. Which part you didn't understand? Obito, why don't you tell me if you don't understand? Please unmute yourself and tell me which part you didn't understand.
Sir, actually, why p to the power n is, how p to the power n is coming, I don't get it, sir.
This you get, this one.
No, sir.
This one you also don't get.
No, sir.
Okay, this you get, these equations. So
Yes,
when I
sir.
asked you that, didn't you understand? Did you understand this? Why did you tell yes, or like why were you shut? Like, don't do this, okay? I mean, this is against the rule of Cheenta. So don't do this. If you don't understand something, just tell me if you don't understand something. Okay, so do you understand these equations?
Yes, sir.
So did you understand? It's like do you know matrix multiplication?
Yes, sir. Yes.
So can you do this matrix multiplication of this row and this column? Do this matrix multiplication. Can you observe that the first one is actually this times this? So what we are getting, the first number is actually pi of Sn, which must be equal to this times this, which is this. The second one will be this times this, like the dot product, which will be this. The third one will be this times this, which will be this. So we are getting that the vectors, the probability vectors at the nth time point is actually p times the probability vectors at the n-1th time point. Did you get this now?
Yes, sir.
Sure.
Sure, sir.
Okay. So now understand that pi1 is equal to this matrix multiplied time a vector. Nth vector is the pi1th vector is this p times this vector. Okay, can you mute yourself? Similarly, this is a pi1. This is pi naught. Similarly, pi2 is p times pi1. So if you replace pi1, it is p times pi naught, right? This is what it's coming. It's p square times pi naught. So we are getting that pi2 is equal to p square times pi naught. So if we keep on doing this by induction, we can show that pi n is equal to p to the power n times pi naught. Did you understand this now? Okay. All of you understood this? Aishwarya, did you understand? I'm not hearing Aishwarya for a long time. Okay. Okay, Shuprabha, I hope you're understanding. Mansi, okay, fine, good. So we are getting that pi n is equal to p pi naught. So if we know how this what is this p, what is this pi naught, we will understand what is this pi n. So p to the power n, sorry. So if we know p, if we know pi naught, then we can predict p to the power n. The question is that how do you predict this p? Okay, how do you predict this p? Okay. So prediction of p is really interesting. So that's where I will use the data. So let's say this is the data we have. So this is from the website. This is the data we have. Okay, it means that in the first year, like susceptible state, itna this were this was the. Oh wait. I did some mistake. Yeah, in the first year, susceptible itna gaya, like number of people we went from susceptible to this to this, and this to this. Susceptible to remove state, and infect state, remove state, you know, and you always know from remove to removed state, it will be all the numbers. So you know this probability always. So we need to understand. The top 4 probabilities. We already know this is 0, this is 0, this is 0, this is 1. We need to know this, and this 5. Therefore, these 5 numbers are there. So question is that how do you predict these probabilities? So let's try to predict. We need to model it probabilistically. So understand this very carefully. what we are doing. Yeah, bolo, any doubts?
So I have a question. So can you please go back one slide?
Sure.
So this data that we have, it's of what time period or what state?
Over just 1 year. So it's like, this is how the data is collected. First year mein they saw they recorded the number of people, okay, and the next year mein saw that what are the changes over time.
Okay, sir. Okay, sir.
Yeah, or maybe I think, or maybe they have done it for many years, okay. So they understand the data susceptible to susceptible kitna gaya. They understand they are susceptible to infected kitna gaya. They did it for some time and they collected the data, all of them. Okay, this is the idea.
Pi n will give what value? Pi n will be that at nth time point, total number of SI and R.
The probability of SNIR. Pi n is what? Pi n is the probability, like the vector of probabilities, okay? Where first one is probability x nth position mein it's S, second mein x nth is position is probability is equal to I. This is the x nth position equal to R. These are the probability vector it's giving. The PMF sort of it's giving. Pi n is the nth PMF, nth PMF. Nth random variable jo hoga uska PMF. Did you understand?
Yes, yes.
And okay, so now understand that how. Okay, so we have this data and we want to understand what is the data, but for that we need to understand the probability. We need to model it by probabilistic. There is a probabilistic model over here, okay, so that we can predict like any parameters or something like that. So how do you predict the probabilities? So for that we will understand something. Understand that, remember we told that P xn is equal to S given xn minus 1 is equal to I plus probability xn is equal to I given xn minus 1 is equal to R, sorry, S, sorry, क्या लिख रहा हूँ? Oh, I'm writing something wrong. This is always equal to 1. So we can write that xn given xn minus 1 is equal to I, this random variable will follow, which we learn in probability 3 is something called multinomial distribution. Multinomial, if this probability is what? PIS, this probability is PII and this probability is PIR. This follows multinomial some n comma PIS, PII and P, not n, M, some M, PIS, PII and PIR. So this n is actually this. From infected to kitna hoga? So it's 502 over here. From infected, how many people are going to susceptible? So this probability is 0. PIS is 0. Okay. But understand is very easily. Oh, I will not use a binomial. Okay, it's like multinomial is an extension of binomial. Okay, but I will not use multinomial anywhere. I will use binomial only. Understand this, that probability, understand that, let's consider this case. From infected, one can go to what states? 2 states only. What are the states? One is infected again and one is removed. So iska probability hai PIA and this ka probability hai PIR. Okay. So if I ask you what is the probability, now understand this follows what? This follows what? Can someone tell me? If I to I is a success, this follows sort of binomial. I to I अगर success ले लूँ, this follows binomial what? Oh, I'm so sorry. Yeah, actually this follows binomial, but what I will do is the following. I will understand that I to I, only this, I to I, only this, xn is equal to I given xn minus 1 is equal to I, or xn is not equal to I given xn minus 1 is equal to I. This follows binomial. Okay, if I goes to I, then it's success. If I doesn't go to I, if it's failure. That's the idea. Understand that here it is what? I goes to I, success is PII. And the rest in the sum is 1, it must be 1 minus PII. So,
Sir,
yeah.
excuse me, sir.
Bolo.
Sir, this slide. Sir, I goes to I's mean, how will you saying that I goes to I's in words actually? I mean, I don't get it. The mathematical things I got, in words, how to got it? How
In
to
words?
get it? Yes. Means, what does it mean basically, actually?
I to I means probability, like probability xn is equal to I given xn minus 1 is equal to I. This is I to I.
Yes. How? Yes.
Now, how? I didn't get your question. Can you? I didn't get your question actually.
Sir, I goes to I. What does it reveal actually?
This
what
reveals the probability xn is equal to I given xn minus 1 is equal to I. This reveals the probability PII. So we are trying to mathematically model that xn given xn minus 1 is equal to I follows, like xn follows binomial, not binomial actually, xn yeah, so in this sums and it follows binomial n, that is the initial xn minus 1 में जितने infected है, like that is 502 over here, comma pii. That means xn is equal to I given xn minus 1. This we have already shown pii, and the rest part is what? 1 minus pii, because the sum is 1, right? Pn is not equal to I is this case and this case, which is 1 minus pii, the probability of that. So therefore xn given xn minus 1, this sort of follows probability binomial 502 given pii. Why 502? Because in fact we have checked the cases 502 cases. So this is what we have got. So it can only have 502 trials. That's the idea. This is, did you get it? Did you get the idea, all of you guys? I don't want to use multinomial. I will explain it to you what is multinomial. But did you understand, guys? All of you. Others. Any doubts? Why it's binomial? We're modeling it by binomial. Polomi, Sriteja, Pratiksha, Priyank, Shwanisha, Sneha, Proma, Shuprabho. Okay, good. So what we have got, xn is equal to I. So we now sort of how we can predict this PII then. So what do you know? The average number of cases that I will be, understand this. The average number of cases xn will be equal to I given xn minus 1 is equal to I. The average number of cases expected is what? 502 NP, right? And the best approximation to this is what? The number of cases we have got, that is 578. So that is the best approximation. We will understand in statistical inference why this is the best approximation. But this is the best approximation we have got. So what is the PII? PII is therefore 478 by 502, sort of approximated, a good estimate of PII. So can you tell me like why PII, like what is the value of PII? Can you tell me? Calculate it and tell me. Zero 0.952. Good. 0.9. Let's check the actual data that they have published. And so similarly, by calculating all these cases, they have published this data that they have published that by calculating this all these cases, they have published this transition matrix. This is the matrix. This is the susceptible, infected, recovered, susceptible, infected, recovered. And this is the probability of found out. Similarly, they have calculated other probabilities also. Okay, you can easily calculate it from this data only. What you do, all of them are binomial, so it's you do this by this, this by this, this by this to calculate all the probabilities. Did you understand this crucial step to understand P, guys? Did you understand this? This is the most important part of calculation, statistical data using. Yeah? Write a boom if you like this till this point of time. The first row is every row is binomial, Sriteja. Every row is binomial. Thank you. Every single row is binomial. Binomial, this is the n, and these are the probabilities that you know. This is the n you will get, and these are probabilities you know. Like these are expected values we are getting, all of you. We are getting. Okay, Pratiksha, are you understanding? Yash, are you understanding? Okay.
Okay, where you have written that expectation of xn, that will be expectation of xn given xn minus 1 equals I, or?
No, it's sort of, this is not correct. In fact, the idea is that we are understanding that given xn minus 1 is equal to I, okay, what is the expected value of the infected people? So if we model it by success, that if it's infected, and failure by not infected, we will get a binomial this model. Okay, since the sum is 1, PI, I say kuch bhi jane ka sum is 1, so therefore it's coming out to be PII. And if this is binomial, the probability of the expected number of infected, the successes, is x502 NP. This is the probability. And this is now we are approximated by this expected number of infected, okay, the success rate.
Means that will be expected number of infected given that it was infected or something like that? Or
Yeah. I have not written that. It's like, yeah, you're right. It is actually wrong. Yeah, you're right. It's given that is infected. You're right. Thank you. Yeah. Expected number of infecteds. I mean, this is a bit different random variable, okay? I'm not writing it down exactly, because if I write it down, you will be confused more, because we have not learned this theoretically. We will learn this in probability 3, okay? But this is to give an idea that what exactly we are doing. I hope you understood. Like, did you understand? Like, the random variable here is something different. Here is we are defining another random variable. Y follows Bernoulli, the binomial 502, PII. Okay, what is Y over here? Y is like it's like what are the trials? In each trial we are observing that whether it's the infected. So we have the final trial, the sum. Okay, we have the sum Y. We know the Y value, that is the number of successes. So we define Y to be a success if Y is coming from infected. Like if it's xn minus 1, say I say it's going to I. Okay, we are defining like that. Okay, and that is exactly expectation of not xn but expectation of expectation of, what should I say, number of i's from if xn minus 1 is equal to I. Okay, expectation of number of xn is equal to I given xn minus 1 is equal to I. This follows binomial. Did you understand, Polomi? I mean, these are mathematically very different, okay? So exactly the reason I didn't discuss this is that if I discuss this, it will be really mathematically cumbersome, which you will become really comfortable with when you will do probability 3 and do more problems. So that's why I didn't do it too much. Okay, if I do it too much, it will be really a bit difficult for you to understand. Just give me a minute. Okay, Polomi, did you understand?
Yes.
A bit, not full.
No, yes, I did.
Okay. So from here we estimated this probability that I have shown you. Okay. Okay. So now we will do it in R and we will understand what really happens. How to do it in R. Okay. Oh, by the way, I didn't tell you something. This matrix, you understand the row sum is 1. So if you multiply this with 1, 1, and 1, this will be 1, 1, and 1. Observe, since the row sum is 1. So it's like 1, 1, 1 vector is actually an eigenvector corresponding to the eigenvalue 1 of this matrix. And these are called stochastic matrix, where row sum is 1. Wherever row sum is 1 and all of them are greater than equal to 0, that is a stochastic matrix. That is actually a transition matrix always. Okay, this is one of the things.
Sir, stochastic matrix, this entire matrix.
Is?
This entire matrix you are calling stochastic matrix.
Yeah.
Okay.
Okay. So what we will do, we will now do it in R. So this is a really big connection point between linear algebra and and probability. Okay. So many people don't know the connections. So it's my duty, I think, to share the connections with you. So let's do now the R, and I will share the. So remember the probabilities. I need you to. Okay, actually I have done it. So no need to tell me. Okay, can you see the screen?
Yes.
So we have these 3 states, S, I, and R. Okay, we have defined a vector over here, and this is the matrix that we have transition matrix we have done defined. First, if you see the row, the first row is 093, 006, 0.01, then 0, then 0.95. That is what you have calculated. Then 0.05, 001. So this is stacked by, and n row means number of rows equal to 3. By row means like how will you assign this? Like first 3 will be the first row, the second 3 will be the second row. If you do by column, this will be first 3 will be the first column, second 3 will be the second column, third 3 will be the third column. If you do by row, then first 3 will be the first row, second 3 will be the second row, third 3 will be the third row. And the list means the naming you will give. So let's do this. So if you see the zone matrix, zone transition, you will see that the matrix exactly what you have got. Okay, the matrix exactly what you have got. Okay, and these are 2 libraries to draw the diagram Markov chain wala and calculate all the matrices. So if you so this is like these are all various difficult stuff over here, very graphical stuff. I am not explaining it. What you have to see the documentation, but I have written it over here. So this is what you will get. This is the picture you will get. Can you see the picture, guys? The transition diagram wala picture. Huh? Hello. Now, can you please? I cannot go back to the chat. Can you please unmute yourself and tell if it.
Yes, sir.
Okay, good. Thank you. Thank you. So you can understand susceptibility goes 0.93% times to like 0.93 probability to susceptibility. This is called the transition diagram. Okay, this is what you will learn in your stochastic process if you have not learned. in your future. Or this is one of the really interesting aspects. So this is the basic idea. This is the basic SIR modeling is essentially the basic of this. Like, so what we're interested, as I told, we're interested in what are the final steps, where it's actually going. So let's understand the final steps. Okay. So let's say initially, the initial vector is, let's say HIV is the new transition matrix. So let's say initially कुछ भी number दो, let's say 0. susceptible are 0.8, infected are 0, infected are really less. Sorry. And this is removed are, let's say 0.98. This is the initial vector. Let's understand where the next this is the initial probability. This is a pi 0. Okay. Now we are multiplying it with this. The next, this is a pi 0. Okay, you can, if you want to write this is a pi v0 is the pi 0. Then this is a v pi 1. Let's see where it's going. So it's a new vector. See, new like probability we have got. Okay, by multiplying it with this. By multiplying with this. So if you ask me why I'm multiplying let, because this is actually in transpose format. Okay, if you see the matrix, that's why you are multiplying with the other hand side. This is not like the vectors here are in transpose format. That's why. Like if x is equal to a y, then x transpose is equal to y transpose a. So here v1 is equal to v1. Actually, the v1 is the pi 1 transpose is equal to pi 0 transpose into HIV, the matrix transpose. Okay. So yes. So let's understand this now. So let's understand why the steady states, where it's going actually. So let's understand. So we know the multiplier. We know that the 100th step will be p0 into vn whole to the power, like p whole to the power 100, right? So by the result we have got. So this is the final idea. What is the number we have got? Yes. So you can understand that it's going towards something. Towards what? Can you tell me where it's going towards? Let's do 1000 then. I don't know. 1000 will be a bit too much for R. Let's do 200. Can you tell me now where it's going? Can you tell me any ideas? You have seen this. Can you tell me? Any ideas? Please unmute yourself. I cannot really go back from R to the Google Meet. Please don't I want you to reply via this voice if it's possible for you. So can you tell me, guys, what's happening? Yeah, no ideas? Guys? Hello?
When the time passes, the probability of recovery is going to 1.
Yeah, it's going to 1. You can understand it from here. So how to find that? You can actually find out by something called the steady states. See, it's going to 1. The final probability 0.0001. Okay. So think about this. That therefore, whatever the distribution is, finally, the R state, whether it's recovered or removed, okay, either they're immune or they are dead. Now you don't know which one it is. Okay, that's the big problem. Whether they're immune to it or they are dead, we don't know. So this is a big problem. So think about, like, it's actually it will be either destroying the entire human population or every human population will be immune to it. Either one of them will be happening. Okay, and that's the bad news. Okay. Okay, so thank you guys. I hope you like this, guys. And if you like this, do do subscribe to our channel. And yep. So
Code with us.
yeah, sure, sure. Okay, if you enjoy this
The
writer,
data,
huh?
sir, the data set and the code.
Sure, I will share it
Actually,
with you.
it will be fine for practice.
Yeah. Okay, thank you guys. And yep, if you like this, go and please like the YouTube link. Then it will be helping us to reach out to more students. Thank you.